Hey guys, gonna do another homework problem. This one's pretty interesting just because you could probably do it just knowing what you know about physics, and because it's just three lever arms and everything is vertical, so you don't get any weird X components that'll throw stuff off. So it's pretty straightforward. But at the same time, we can do it with a free body diagram of each individual member, and that'll help kind of just practice the problem. So let's give it a shot here. Let's see. Hope I remember to move the page. Alright, so I don't think we need this top member, just to consider that like a fixed pivot there. So we have three multi-force members, so EFG, CDS, and ALB, and then we have two force members, ED and GB. So this is good practice, just doing a free body for each of these, because you can practice making sure that all of your force arrows, your force vectors, are in the right orientation. So let's pick AB or ALB first. So we have A, L, B. Our load here is mg. That's what we're solving for, right? We're solving for that mass. Our distance here, I'm just going to write it in centimeters just because everything has a 0 at the end. As long as it's proportional, we're good. So 1535 there, and then overall that means 50 here. Okay, and we'll just assume they're both going up, F and FB. Okay. So kind of going around. So now we have a two-force member. Right, we have, so that goes from B to G. And so the main thing to remember when you're doing your arrows is if you have another one, so here we have FB, it has to be here in the opposite direction. So we're going to pick it down. And again, it's okay if you mess up on the original one, just as long as you're consistent throughout. So if you pick down here, as long as that's up, you're good to go. And then two force members give you the advantage that you can say, alright, well, the opposite here, this force here has to be that force, right? There's only two forces on it, so they just have to be equal and opposite. And I'm going to call it FG, but we do know that to sum up the forces, right, FB is going to equal FG. Alright, so keep going around. Now we have EFG. Okay, so and again here, since we have FG here going up, we got to have FG going down. And then the other two, just you could pick them however you want. I'm kind of lazy, so I'm just going to pick them up, and whatever happens, happens. We'll just deal with the signs later. Alright, so on this one, it's 15 centimeters, and then going that way, 25. So overall, that will be 40. Then the next two force member coming down, we got ED. So same thing, since we have FE, that one's going up, we picked it up, so FE over here has to be going down. That's the main thing, the main reason we're doing this whole thing is just to practice this. That's going up, that's got to go down. Two force member, if that's going down, this has got to go up. And In actuality, you could probably not put it up just as long as you take care of your signs, but I'm going to draw it this way. And then, again, 2 force member, FE is going to equal FD. And finally, what do we got? C, D, S. S. I drew that a little bit out of scale, but whatever. So FD's going up, FD's going down. That you do have to make sure. I shouldn't probably have said that before, but as long as they're drawn equal and opposite on the 2 members, that's really the critical thing here. And then we know this is going down. It's a mass 2 kilograms times G. And then what's distance from D to, let's look at that distance there. That's 10. And then D to S, 25, 15, so 40 plus 45, that's 85. Alright, so we have everything drawn out. Now, I'm going to just slide this up so I can keep track of the equations. I'm just going to start writing them here. So I'm going to just work backwards just because I have 2G here. I'm going to just work backwards. And the way I kind of think about it is we're going around this, basically this chain here. So since we're and this is forgot it because we're probably I'm just gonna take the moment around here, because what we do know is I want to go from figure out FD in terms of 2G, and then I'm gonna go up here, find FE, go back over here, and then take the moment around here so that I could find FG, go from FG to find FB, and FB to MG. So since these are all the forces are in the same direction, it's easy enough just to do a moment. So you just got to be smart about which point you're picking and get what you want. So we'll do the first one, we'll do the sum of moments. Since I'm looking for FD to kind of get up into here, I'm going to do the moment around C. I'm picking clockwise, that has to be 0. So obviously I already picked both of these in the wrong direction, or one of them in the wrong direction, just because they both have a moment in the same direction. But that's okay. So moment around C, that means we're going to get 10 times FD plus 95 times 2 times G. So that means FD is going to be 2 times 95 divided by 10G. And so if we go up here, that means that's what, minus. And then up here, we're going to get that's going to be equal to FE. So now let's do the moment on the second one. Since we have FE, I'm looking for FG, so I could get back to B, so we're going to do moment around F. That's equal to 0. So, and both of those are in the same direction as well. So here we get 15 times FG, positive direction, and then same over there, 25 FE. And so that means we're going to get FG is equal to minus 25 FE divided by 15, and then substitute that into there, so the minus is drop out, so we get 2 times 25 times 95 times G over 10 times 15. I'm just going to keep the numbers in, so I don't have to get the calculator out just yet. Alright, so last one. This is FG. Numbers FB, so I can just say this is equal to FB. And then finally going back here, I want to get MG, so that means, so I want to find what M is. And I know FB, so I want to take the moment around A. So we'll do it here. So the moment around A, something, clockwise 0. Alright, so around A, the MG is clockwise, and here the FB is counterclockwise. So we can solve for M now. That goes to the other side. We get 50 FB over 15G. Substitute that whole thing in there. So we get 2 times 25 times 50 times 95G over 10 times 15 times 15, and I'm going to just try to do some simplifying here. So 2 over 10, that's a 5, 5 over 25, that's a 5, 5 and 15, that's a 3, right? 5 out of both of those, that's a 3, that's a 10, so I get 9, 50 over 9 kilograms, and then calculator out. 50 divided by 9, 5.555, so got approximately 106 kilograms, and then that's what the book said. So, and you can see, going through this in reality what we did, right? Like, I mean, these are really just all the terms in front of here are just the mechanical advantages for each of these levers, and we multiply them together. But I thought that would be a good practice problem, just so that you can really remember that when you break these machines apart and do the free body diagram of each of the things, the main thing is make sure when you're doing it, the force that is this same label between the two members is in the opposite direction. That's key. I mean, it doesn't matter which way you pick. Like you noticed here, we got a negative, but it works itself out if you do it right and keep track of the signs. Alright, so I hope that was helpful, guys. Have a good day.